I'm going to demonstrate how to use Multisim to simulate a simple DC circuit, and this will be your first exposure to using Multisim. I'm assuming that you followed the directions and installed Multisim 2012 from DFS. So now click on the Start button and select all programs. Go to National Instruments. That ought to be there once you installed Multisim on your laptop. Go to Circuit Design Suite and then click on Multisim 12. Notice that a design project has come up, and the name of your file that you'll be clicking on to continue working with this after you've saved it once will be right here in a design file. You can just click on Design 1 and bring the circuit back up again. So now let's make a DC circuit. Here's the place that we're going to be drawing our schematic diagram. And if we go up here to the Place menu, Component, and then notice that I have all groups chosen, and we can just search now for a DC power source. That's what they call a battery in Multisim. So I'm just going to type DC, and notice I get a bunch of things that start with DC, and one of them is a DC current source, as you can see here, and down here is the DC voltage source, which for some strange reason Multisim calls DC power. That's a DC voltage source, and notice the battery symbol is used to represent it. So I click OK, and then I place my DC voltage source wherever I want, and I can say OK now. Now notice I'm able to deposit another battery in the circuit if I want, but I don't, so I'm going to right-click my mouse to get rid of that battery. Otherwise I could deposit several other batteries in the circuit. So now let's say I want, let's get a current source. So let's do the same thing. Place, Component, DC, and now I'm going to click on DC current and say OK. Let's put our DC current source over here somewhere. OK. And then right-click to stop that mode. Now let's just for fun get a DC dependent source. Let's see how we would do that. So go to Place, Component, and this time I'm going to type controlled. No, that's not going to work, I'm sorry. It's ABM, that's right. It's not called a controlled source, it's called ABM. That stands for Analog Behavioral Model. And notice it's got the right diagram for a dependent current source, and if I click on ABM voltage, I get the right diagram for a dependent voltage source. Let's make it a dependent current source. Click OK, and we can deposit that right there. Say, what if I want the arrow to point down instead of up? All I have to do is hit Control R for Control Rotate. Control R rotates it 90 degrees and then rotates it 90 degrees again. So now I have my dependent source pointing downward. So let's imagine that's what I want, and let me deposit it right there. Now we'll worry about assigning the strength to it later. I'll right-click to get out of that mode. Now I'm going to go to Place, Component, and I'm going to search for a resistor. And if I pick one of these resistors whose values are already known, I get a picture. I don't want that. That's not a schematic. So go to Resistor Rated and click OK. And now I'm going to deposit several resistors in the circuit. One here. OK. One here. OK. And let's put one up here, like there. OK, and just for fun, let's make one vertical. Remember, you do a Control R, and I've just done one Control R, and just for fun, I'm going to put a resistor there vertically. And now I'll right-click to get rid of the resistor depositing mode. Now I have to interconnect these elements, so I'm going to bring my cursor over near a dangling node, a dangling lead, And notice how the cursor changes from an arrow to an X. That means I can now press down my left mouse button and drag a wire. Here I can let up on it and then press down again, and that guarantees I get a bend in the wire right where I want it. And notice I can now do a left click to deposit that wire and it turns red. So now I have a wire connecting these two elements, and let me do it for the rest of these. So here to here, and now I cannot continue a wire here. I have to go over to a dangling node, let up, click, and that guarantees the bend goes where I want it. Press it, drag it. See how easy it is to wire up a circuit in Multisim? It's not just easy, but I think it's fun. Well, I hope you do too. Okay, let's take this down to here, and this over to here, and this down to here. This will be our ground node, and I'll just run this all the way across, let up, bring down. Oh, well, that didn't look so good, did it? So whenever you have an error like this, well, I'm going to left click. I'm sorry, that's not right. I'm going to click on that wire that I don't like because it got ugly, and do it again. So let me try it again. Sometimes that happens. Let up, press down, and I want to stop right there. Let up, press down. You don't always have to let up and press down. Sometimes it usually bends where you want it to. And then don't forget to click when you get it to its destination to actually connect the wire with a little connection dot, as you can see. So now we've built our circuit that we want to simulate, but I have to adjust the values of everything to the values I want. And also, every Multisim simulation needs a ground node. So I have to go back up to Place, Component, type in ground. Oop, and that nice ground symbol shows up there. Okay, and let's put ground down here. Okay, and let's connect it. Just that easy. Isn't that fun? So let's go in and adjust the values of everything. Let's say that we want this to be a 10 volt. So I'm going to double click on the 12 and change it right here where it says voltage to 10. Now there's a whole lot of other parameters that are important if you're doing an AC analysis, which we're not going to worry about right now. All we have to do is worry about this box right here, and notice you can change the units. We want it in volts, which is the default. So that looks good. I have now not changed. Okay, try that again. I forgot to say enter. Okay, or OK. I can either hit the enter key or I can hit the OK button. Now it's 10 volts. Now also, what if I want to drag the 10 volt label over to the left? I can do that. I can just click on it to get that selection box and drag it over here. I can do the same thing with the component label if I want to. I can position things by dragging after they are first drawn. I can even move things a little bit. Like I can click on this current source, and I can get a dotted box, and then I can draw the dotted box, drag the dotted box down, and make things look a little prettier, perhaps. Do the same thing here. I can even draw part of the whole circuit if I want. For example, let's just move this whole circuit down, because as I've drawn it, it's gotten pretty up close to the top. So I can, with my left mouse button, dragging a box around it, I now have it selected, and notice there's some big squares in the circuit as well as small squares. If I go to any one of the big squares, I can drag the whole blasted thing down and maybe over to the right a bit. So I've got more room on my drawing paper. Something else I probably would like to do, if I click off to the right, left click off to the right somewhere, I can get rid of all those selection boxes. But let's put a label. You really should have a label on every circuit that you submit. And so let's do that by going to Place, Text. It could be a Control-Alt-A would be another way of doing that. But now I can click where I want my text and I can type in a label. I'll call this a demonstration circuit for DC analysis. Something like that. What if I don't like the font, or what if I want to make it bold-faced? Well, just click on that box, do a right click, and go to font, and you can change it to maybe 14 bold. Bold italic. Let's really make it stand out. So there we have it, and now I can drag that box by just clicking on it. I can drag it over and get it centered. So that's how you can put a label or a title on a multi-sim simulation. So there we go. We'll be back for more in a moment. Okay, I'm going to change a few more of the component values. Let's just change this to 5K by left clicking and changing the box right here. 5K. Let's change this to 500 ohms. Left clicking, 500, and click down to get to ohms. Okay. Let's change this to 5 mA. Left clicking, 5, and then click the box here to get to mA. And now it's time to do the harder part, which is to set the strength of the ABM source to make it into, say, a voltage-controlled current source. To do that, let's just say I want to get the voltage plus to minus across R1. How do I indicate that? Well, I'm going to have to find out what these nodes are named. By Multisim, it automatically numbers the nodes, or the nets, as they call it. So right-click and go to Properties, and you can see it's called Node 1, and we can display that node by clicking that box. And if I hit Enter, you can see the node number is now displayed. However, sometimes we want to rename the nodes so that they're not just cryptically numbered, but given a more meaningful name. So I'm going to go back and rename that node something more meaningful. Right-click, Properties, Preferred Net Name is where I can change the name of that net to a custom name, like maybe vSource. And then I'll hit Enter, and you can see the node has now changed. Do the same thing here. Properties, I'm going to call this iSource, just to give it a more meaningful name. Oop, I forgot to click the box this time. So I've got to click the box so I display it as well. Sorry. Now it says iSource, and I can drag the name anywhere I want to make it a little more convenient positioning. Let's give this a name too while we're at it. A custom name. I'm going to call it, instead of node 3, I'm going to call it dependent source. And then remembering to click that box and hit Enter, I now have named that node. And I'm going to drag this over near so it's more conveniently positioned. Now, let's click on the strength of that dependent current source, and I can enter a formula to indicate what it depends on. And the way you indicate the voltage from here to here, plus on the left, minus on the right, is using capital V parentheses. So I'm going to multiply the strength of this source by 0.0005 Siemens. So I'm going to type 0.0005 and then the times symbol, and then capital V, and then the name of the node on the left, VSRC, that was the custom name I gave it, and then comma, not a minus sign, but a comma, ISRC, and then ending parentheses. Now I can hit OK down here, and you can see now that the strength of that dependent current source is what I wanted it to be. I'm going to be multiplying 0.0005 Siemens times the voltage here with respect to the voltage here, plus to minus. And so now we're ready to simulate this circuit. Now we're ready to simulate, and the way you do that is you have to indicate what nodes and maybe a voltage and a current can be measured using what's called the measurement probe. So to place a measurement probe at a place you want to measure both node voltage and current, we go to simulate, not place, but simulate, then go to instruments, and then go down to measurement probe right here. Simulate menu, instruments, and measurement probe. And clicking on that, I bring up this little yellow thing. Let's say that we want to measure the current downward right here. So I bring the measurement probe close to that, and I get a little arrow pop up on the wire. Then left clicking deposits the measurement probe. Now that's going to measure the current downward as well as the node voltage here with respect to ground. If I want to turn that arrow around and measure the current the other direction, I'm going to right click on the arrow and click on reverse probe direction. That turns the arrow around, as you can see. Also, this probe displays a lot of things we don't need, a lot of things that are used in AC analysis that we don't need right now. So I'm going to right click on this probe display box and go down to Properties and go to the Parameters tab and click this box, deselect it. That deselects all of these items from the probe box. Now I'm going to click on just V and I, the DC voltage and the DC current, at that point and hit OK. Notice my probe box has gone down to just V and I, which is all that I want. I can drag this probe box wherever I want to make it convenient. So now I'll be measuring the current upward through that wire, and I'll also be measuring the voltage here at this node with respect to ground. Let's place another probe box. Simulate, instruments, measurement probe, place the probe arrow. Let's say we want to know the current and the node voltage here, and then left click. Then right click on the display box, Properties, Parameters, deselect, and then select the V and the I. Or just the V or the I if you don't really want both, but let's say we want both. And so I'm going to drag this display box, which is now running right over the diagram, I'm going to put it up here. So now I've got two probes set, probe 1 and probe 2. I think that's enough. Let's actually run the simulation now. I just noticed that the units were missing on this probe box. You can always go bring the cursor up here till you get the double arrows and drag this side of the box, there, drag it out. So now the units appear. And now you probably would want to go back and redo the snip. Oh, let me move this up a tad so that the eye source can be seen. Okay, now we're ready to do the Windows snip once again. But I won't bother to show that again. Let me show you now how to display the simulated results in tabular form. It's different from using the probes. Now for the homework, I'm happy with you just displaying these probes, but you might want to experiment with this other method of displaying the results. So all you have to do is go to Simulate, but this time don't go to Instruments. Instead, go down here to Analyses and pick the DC operating point analysis option, which is right up, which is right up there at the top, as you can see. So clicking on the DC operating point analysis, we now brought up the DC operating point analysis window, and we can now add various things to the selected variables for analysis. I had to erase them since I put them up there earlier. But let's look at the node voltages at the source and holding down the control button, at the current source, and at the dependent source. Those are our three node voltages, and I can click Add, and I've added them. Let's also look at the current through the voltage source, So I'll add that as well. And perhaps even the power through the voltage source, delivered by the voltage source. It might be the power absorbed by the voltage source. We'll see if it comes out negative or not. We could also look at the two probe currents, which of course we're already displaying, but let's add those as well. I held down the control key to select two things at once. Okay, now we're ready to simulate. So down here is the simulate button. Just press that. And lo and behold, a nice little grapher view shows up with all of the parameters displayed. And notice the grapher window, of course, better agree with our probe windows. I need to run the simulation again, and now I can stop it. And there are the values in the probe windows. And notice that they match up nicely. The voltage at these two nodes is both 12.5 volts, and that shows up here and here. The voltage at the source voltage node is, of course, 10 volts, and even though we didn't display it with a probe, we can see it here. We've asked to have it displayed here. Here are the two probe currents that are also being displayed here and here. Let's see, what about that power? Is it power sourced or power absorbed? Looks like it's power sourced, 50 milliwatts by V1. So there's the grapher view window, and you can use the window snip tool to snip out the table and display it if you want to on your homework, but like I say, you don't have to. Another thing that's neat is you can go to Tools, Export to Excel, and say OK. And that brings up an Excel icon that you can click on, and there we have an Excel spreadsheet created with our data that we asked for, and also the node labels that relate to it. So that's a nice little thing that you might want to make use of as well, but again, you don't have to.